Hey everyone, in this video we'll learn how to graph logarithmic functions, and over here we actually have an exponential function graphed. F of x equals 2 to the power of x, it's graphed in blue, and the reason why we have this graphed is because we want to show that logarithmic functions are the inverse of exponential functions. They are the inverse. So every single property you can think of when it comes to an exponential function, it is reversed for logarithmic functions, and you'll see exactly how. So right here we have f of x equals 2 to the power of x. You'll notice its domain and range right here. The domain for an exponential function is from negative infinity to infinity, all real numbers. And the range for this one is from 0 to infinity, not including 0. And of course, we have an asymptote at the x-axis, or at the line y equals 0. So let's go ahead and plot our logarithmic function g of x. So g of x equals log base 2 of x. So log base 2 of x. So again, they both have the same base. Right here in f of x, we have base 2. And in g of x, we also have base 2. So these are inverse functions. So what does that mean for our situation right here? What are the domain and range? It's reversed. So now the domain is restricted. The domain goes from 0 to infinity. And that makes sense because x can never be a negative number. As we've mentioned in a previous video, you cannot take the logarithm of a negative number. It doesn't work. And the range is actually all real numbers. So the range is from negative infinity to positive infinity. So the output of a logarithmic function could be anything, any real number. And what is the asymptote? So for the exponential equation, the asymptote was at y equals 0. But for a logarithmic equation, the exponent, or the asymptote, is at x equals 0. So it has an asymptote at x equals 0, which is actually the y-axis. So with that said, let's go ahead and plot this logarithmic equation, g of x equals log base 2 of x. And what we'll actually do, let's go ahead and draw the identity line, because we know that for inverse functions, they are reflected over the identity line. So we have this identity line right here, y equals x. So on this line, at every point, the y-coordinate and the x-coordinate are the same. So all we have to do to reflect this across the identity line, to plot g of x, let's start with this point right here, 0, 1. All you have to do is switch the x and y coordinates. So 0, 1 becomes 1, 0. Now right here, 1, 2 becomes 2, 1. And over here, 2, 4 becomes 4, 2. And right here, 3, 8 becomes 8, 3. So 8, 3, which is about up here. Good. Now, over here, negative 1, a half is a half, negative 1. And then you'll see that the asymptote is at the y-axis. It never really touches the y-axis. And there we go. That is a logarithmic equation. That is g of x. That's g of x equals log base 2 of x. And you'll notice that it is reflected across the identity line. And you'll also notice its domain, as we saw here, it's from 0 to infinity. It never touches 0, so it goes from 0, not including 0, all the way to positive infinity. And the range is all the way down negative infinity, and it goes all the way up to positive infinity. So the range is all real numbers. So that's how you graph this logarithmic function. And let's go ahead and just graph a logarithmic function that's been shifted a little bit. So let's call this one h of x. Let's graph it in green, h of x. Let's actually choose red because we have the identity line in green, so h of x. And we're going to shift it a little bit. This will be log base 2 of x minus 2, and then minus 1. So this is essentially g of x shifted to the right by 2, and it's shifted down by 1. All the same rules for transforming functions that we've covered in previous videos on how to transform functions. All those same rules apply here. So we're shifting it to the right by 2, and we're shifting it down by 1. So how do we graph h of x? H of x equals log base 2 of x minus 2 minus 1. All we have to do is take g of x and shift everything to the right by 2 and down by 1. So we could start here at 1, 0, to the right by 2 and down by 1, to the right by 2 and down by 1, to the right by 2 and down by 1, the right by 2 and down by 1, to the right by 2 and down by 1. So right around here, actually. So if we go ahead and connect all these dots, we've graphed h of x. So h of x in red, it is a logarithmic function. And you'll see that the asymptote has actually shifted. The asymptote now is at x equals 2. So x equals 2 is the new asymptote for h of x. So that's how you graph logarithmic functions. I hope this video helps, and if you have any questions at all when it comes to graphing these types of functions, please leave them down in the comments below, and thank you for watching.